Everyone, and welcome to lesson 10.2, day 1. Today we are going to talk about tangent lines to our circle. A tangent line is a line that will intersect our circle on the outside at exactly 1 point. So if we see in this example over here, we have this line LP that it is touching our circle at exactly 1 point, which we call the point of tangency, and that's happening at point P. An important theorem about tangents in our circle is that when we draw a radius to our point of tangency, what's going to happen is it is going to be perpendicular. So we will create a right angle at that point of tangency. And also, if we have a tangent, or we have a line that's perpendicular at that radius, then it will also be considered a tangent line to our circle. So in number 1, we want to decide, would this line be a tangent to this circle? So notice we are being given these angle measurements here, are these side lengths, and we're trying to decide basically, are we creating a right angle at the point of tangency? That's the question. Is there a right angle there? Well, if this is going to work out to be a right angle, what's going to happen is the side across from our potential right angle, 17, right? If we add those two pieces together, that is going to have to fill the Pythagorean theorem as our C value, and it's going to have to equal our A squared plus our B squared. Now, it's not labeled on this picture, but if our radius here is 8 units, so is this radius over here, so that we can test, does this left-hand side equal the right-hand side? Because again, we're trying to decide, is this a right angle? Yes or no. So what we're going to do is we are going to test using our calculator, does 17 squared equal 15 squared plus 8 squared? And the answer is yes, it does. They both equal 289. So this, in fact, is going to create a right angle. So we would say, yes, that's a tangent line. In our second example, again, notice our point of tangency is over here at A, and we're trying to decide, is that a right angle? Does 11.3 squared, the side across from that right angle, and our biggest side, does that equal 10.3 squared plus 5.6 squared? So we're going to take 11.3 squared, and again, we're going to test, does that equal 10.5 squared plus 5.6 squared? And the answer here is no. Okay, 127.69 did not equal 141.61. So because a squared plus b squared does not equal c squared, this is not creating a right triangle. So it is not going to be a tangent. Here is one for you to try. Again, you are testing out, does the biggest side, in this case C, equal a squared plus b squared? Yes or no? Is this line tangent? All right, down here at the bottom, we have a couple of examples that are saying, okay, assuming that this line is a tangent line, what would the length of the missing segment be? So again, your right angle is always going to come at that point of tangency. So when we create this right triangle, our biggest side is always the side across from that angle. So step 1 is always mark the right angle. So we know what's going to be our C value. So in this case, 17. And we want to see, does that equal our missing side squared plus 10.2 squared? Well, to solve this, we are going to subtract 10.2 from both sides. 17 squared minus 10.2 squared is 184.96. And then we're going to square root to get our final answer. X ends up equaling 13.6. On our second example, again, start by marking that right angle. Okay, mark the right angle. Well, our point of tangency is here, which means that's where our right angle would occur. And then our C value is the side across from that. So again, we have a squared plus b squared equaling our c squared value. So 10.5 squared has to equal our missing side squared plus this side squared. Now notice they only gave us 4.2, which is half of that whole side. Well, remember, all of our radii are the same size, 4.2 and 4.2, so a total of 8.4 for that missing side. And again, when we're solving for one of those legs, we're going to subtract the leg that we do have. And then we will end up needing to square root. This is 39.69. And as we square root, we end up getting x to equal this time about 6.3. On the back page of the notes, okay, we have a couple more examples. This time they want us to find the measure of this side. Again, our point of tangency is right here, which means our right angle would be at that point, and the side across from it is our C value. Now, again, they didn't give us to start this whole side, so we need to add together those two segments to get the whole side of our right triangle. Our C this time is 17.5. Now, again, they didn't label on this part either, this other missing side, but we know that this side is going to be the same as our radius here, because all the radii are equal. So we know that's going to be 10.5, and then we're looking for that last side of our right triangle. So subtract over the 10.5 squared from both sides. 17.5 squared minus 10.5 squared is 196. And then when we square root the 196, x ends up equaling 14 this time. On our last example, on example D here, we have officially just this missing side that we want as our final answer. However, we know that if this is my point of tangency, this whole side is going to be my hypotenuse, or I guess we could even call it, just so we know, the C value this time. So in order to find that final question mark, we still need that hypotenuse first. So our hypotenuse squared is going to equal the A squared and the B squared, which are both being given. So add those two together, we get 302.76. And when we square root, our whole hypotenuse ends up being 17.4. Now again, that's the length of this whole side. And I only want this, not that piece. I want the blue piece. Now I know, however, that my radii are equal. So if this is 12, so is that radius. And I can find my question mark by taking that big side minus the smaller side to give me my final answer of 5.4. All right, down below, we have two examples for you to try. On this first one, you are finding the length of that radius. Again, make sure you mark your point of tangency and your right angle. And then in this second one, again, you are finding the length of this tangent segment out here. Again, think about where your right angle is going to be occurring to help you actually solve for your tangent. All right, down here in example 3, they are giving us that we have these tangent segments shown to the circle, and they are giving us a little bit of information in the first one that E to T is 16, D to P is 41, and we want to find the length of that tangent segment. E to D is our goal. Well, a reminder, your right angle is going to come at the tangency point, that point of tangency. So we know angle E is our right angle here. So we know that this whole side, D to T, would have to be our C value. Well, a reminder, in order to find that whole thing, C, we know that this piece is 16, so is P to T, and that whole side C would have to be 41 plus 16 for a total of 57. So really, if we look at this right triangle, if I redraw it over here, here's my right angle. My C value is 57. My radius here is 16. I'm looking for that last side. So C squared equals A squared plus B squared. Subtract over the 16 squared. We end up with 2,993. And after square rooting, we can round to the nearest tenth. X is 54.7. Now on our next example, again, they are giving us a couple different things this time. D to P is 37. F to T over here is 19. Again, we want the length of the tangent segment out here, which we know is where that right angle will occur. Well, similar to that last one, again, P to T and T to F are both radii, so they both have to be 19, which means this whole side, D to T, would have to be 37 plus 19, so 58 degrees. Or not degrees, 58. That is, again, across from my right angle, so that is my C value. And then I'm looking for x squared plus 19 squared. Subtract over the 19 squared. 58 minus 19 squared is 3,003. And then we are going to square root that to get our final answer of 54.8 for our tangent segment length. All right, the last one is for you to try. Again, start by labeling your picture. This time they're giving you E to T and D to P. And they want you to find the length of this tangent segment out here. Now, reminders, your right angle comes at that point of tangency, and you need to find the length of D to T to help you first before solving. Thanks everyone for watching. We'll work more of these in class.